Hello, this is FASTECH. From now on, I will introduce the actual application example of Ezi-SERVO. The first application case is LC dispensing machine. LC means liquid crystal. 2 glasses are needed to make LCD panels used for this TV and monitor. It is the TFT panel on the left and the color filter on the right. A certain amount of liquid crystal is dropped on the TFT panel as shown in the picture. Glue is applied to the color filter as shown in the picture. And then, the part where the liquid crystal is dropped on this panel is bonded to the color filter on the right. When bonded together, the TFT is this part, the color filter is this part, and this is the glue, and this red part is the liquid crystal. And when it is bonded, this liquid crystal spreads quickly. For example, when you press the panel with your hand on the TV, that is, when you press the liquid crystal, the pressed part is changed color. The reason the color changes is that the liquid crystal is liquid, so when it is pressed, the liquid crystal escapes to the other side and the amount of liquid crystal changes in the pressed part, causing the color to change. For this liquid crystal volume to be constant, this drop must be constant. In other words, it is a very important process that determines the quality of the color of the LCD panel depending on how precisely and uniformly, or quantitatively, this liquid crystal is dispensed. Therefore, the 32000 ppr encoder, which has the highest precision in Ezi-SERVO, is also applied to this machine to increase the precision of liquid crystal dispensing. If a 5-phase motor or other company's closed-loop stepping motor are applied to this liquid crystal dispensing, the position accuracy is not constant, so it is impossible to dispose of a certain amount of liquid crystal. In addition, in order to bond the panel and the color filter, the glue must be uniformly applied to the color filter. If this glue is applied more on one side and less on one side, as you can see, the applied part is not straight, it is applied like a snake. In this case, the area on which the liquid crystal is placed changes. The amount changes when the area changes, and the color changes when the amount changes. In other words, constant liquid crystal dispensing and uniform application of glue are key to improving the color quality of LCD. From the conclusion, in the past, customer used a AC servo when dispensing this liquid crystal. In order to drop this liquid crystal, from the perspective of the motor shaft, it is necessary to move to a high-speed short pitch. However, if you use a AC servo at this time, there is a high possibility of overshoot. Due to the overshoot, the amount of liquid crystal was not dispensed uniformly, and the engineer was forced to tune the gain every time, and the cumbersome and laborious work continued. However, if you use FASTECH Ezi-SERVO, of course, the stepping motor will overshoot, but the amount is less than that of the AC servo. Also, no gain tuning is required. On the other hand, since the amount of AC servo is not constant and varies depending on the gain tuning, we proposed to apply the Ezi-SERVO. But because of the customer's general perception that it also could not be a stepping motor when the AC servo was not available, it took a year to suggest and do a test for replacing from AC servo to Ezi-SERVO. This is the actual liquid crystal dispensing machine. It took a year to get the opportunity to test the Ezi-SERVO. But after the engineers actually tested the Ezi-SERVO, the AC servo that was on the entire machine could be replaced with the Ezi-SERVO at once. I explained earlier that the glue must be applied to the color filter regularly. In this case, it is necessary to use a laser sensor to control the gap between the panel and the dispensing to be constant. This machine shown in the picture is the machine that controls the gap between the nozzle and the panel through a laser sensor. In order to dispense a certain amount, the distance between the color filter and the nozzle must always be constant. In other words, since gap control to keep the distance between the nozzle and the panel constant is necessary, an expensive laser sensor is applied to this part. The color filter looks flat on the surface, but is curved. Nozzle must maintain the height between the bented color filter, and apply the glue following the gap. That gap is 50 microns. For example, if the distance between the nozzle and the panel is 100 microns apart, you have to move 50 microns at a time. If this spacing is not constant, such as 50 microns, if the distance is far apart, the glue will be less applied. Or it will be more applied if applied closer. This means that the distance between the nozzle and the panel is always constant in order to apply this glue evenly. For example, if your goal is to keep a gap of 50 microns, if the nozzle is 60 microns away, you'll have to order 10 microns down. When commanded like this, the Ezi-SERVO goes exactly 10 microns. Also, if you are 40 microns apart, you need to change the direction of the motor because you have to up 10 microns. Even at this time, the Ezi-SERVO moves up to exactly 10 microns. However, in the case of a 5-phase motor or other companies' closed-loop stepping motor, position accuracy and lost motion are not good. So there are times when it goes exactly 10 microns, and sometimes there are times when it doesn't, so even coding is impossible. In the case of AC servos, of course, position accuracy and lost motion are good, but the possibility of overshoot is high. So if an overshoot occurs and the motor moves too much, the glue may not be applied evenly. There is even a risk of damaging expensive panels by contacting the nozzles and panels. The graph you see is the measurement of the response of the AC servo and the stepping motor when the AC servo and the stepping motor do up and down by 10 microns under the same conditions. As before, the nozzle was not gap controlled by following the distance from the panel. But this time, 10 microns were only up and down in a fixed position to see the difference in response between the AC servo and the stepping motor. If you look at the graph, the red graph is AC servo. In the same case of 10 micron up and down operation, the AC servo up and down 3 times at the same time. Of course, there is gain tuning, but if you increase the gain, there is a possibility that the glass may be damaged due to overshoot. In order for the servo to move without overshoot, the gain cannot be raised, which will result in a slow response, so it is not possible to quickly up and down. In comparison, Ezi-SERVO up and down 9 times without overshoot at the same time. If you use Ezi-SERVO, it means that the speed of the machine is calculated to increase 3 times. For example, if the speed at which the glue is dispensed is 100 mm per second, it will move 100 mm for 1 second. And if you use a AC servo, the gap control, that is, up and down, is done 3 times. So the point to be corrected will be once every 33.3 mm. However, since Ezi-SERVO does this up-down motion for 9 times at the same time, it will add 3 times even between 33.3 mm. If the AC servo is used even within the same 100 mm, due to the response which eliminates the overshoot, the late response will be calibrated sparsely as before. If there is another bent point of the glass in between, the response will be slower to compensate for the gap. So, what's happening if you increase the speed by 300 mm per second, that is, triple the dispensing speed? Because Ezi-SERVO does up and down 9 times, as a result, it will correct the position same as the AC servo did 3 times. This means that the machine speed is tripled. In other words, by changing one motor, it has tripled the speed of the machine, increasing actual machine productivity by 3 times. In other words, there are many machines where Ezi-SERVO can perform higher than AC-SERVO if the motor is well selected according to the machine. I will introduce a small actuator as the next application example. In the case of small actuators, there are many high-speed short-pitch motions that move short distances at high speed, which is the advantage of stepping motors. And it is sufficient to apply Ezi-SERVOs instead of AC servos. So, it is an effective market for cost-effectiveness. As previously shown, in the case of a small actuator, all the torque of the AC servo cannot be used because the moving distance is short. And it is an application that can take advantage of a stepping motor with no hunting characteristics at the target position. Therefore, in the past, mostly AC servos were used, but many customers who know the advantages of stepping motors use Ezi-SERVO. Lastly, I will show you examples that Ezi-SERVO actually applied to a small precision stage. This is Japan's Tsuruga Seiki Konyo stage used for camera module alignment equipment. You can see that Ezi-SERVO is applied. In addition to Japanese stages, you can see that Ezi-SERVO has been applied to the Mentor stage, a Korean small precision stage company. You can see that FASTECH's Ezi-SERVO motor is applied to Taiwan's small precision stage. On the FASTECH website www.fastech-motions.com, you can download product-related materials such as catalogs, manuals, drawings, and watch demonstration videos and webinars. Also, if you search FASTECH on YouTube, you can see about more than 100 demonstration and webinar videos. Thank you for listening.